as legislation affects water heaters more and more, we see more safeties, more complex components, and sequences of operation, and so that doesn't always lend itself to a one-size-fits-all or doesn't always lend itself to a DIY approach.
Welcome to the Fine Homebuilding Pro Talk Podcast, a regular discussion with building industry professionals. This is Senior Editor Patrick McComb. Today I'm joined by Spencer Pope of Bradford White. You can find the Fine Homebuilding Pro Talk Podcast and the original Fine Homebuilding Podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. Spencer, it is a pleasure to meet you. Thank you so much for being on the show.
Thank you for having me. I'm excited to be here.
Okay, so we should tell folks right off, Bradford White is the big water heater manufacturer, and you're standing in front of what looks like a dozen water heaters behind you. Can you tell me about that for starters?
Yeah, I am in we call it ITEC. It's the International Technical Excellence Center. It's where we host in-person training classes for professional contractors. And so this is a live fire lab. We can fire up to 5 million BTUs here. And I was hoping it would make a decent background. So I appreciate you asking about it.
It's fantastic. So you have gas and electric water heaters represented there?
That's correct. Yep, wow. We do have natural gas heaters in this lab. We do have the ability to hook up propane heaters, and then we also have electric service here, yep.
And I will tell folks there are tank heaters represented of all sizes, and it looks like you have some on-demand water heaters there too, right?
That's correct.
Wow, very cool. So can you tell me what you do for Bradford White, please?
Yeah, I am the lead technical trainer here at Bradford White, and I'm also the team lead for our technical support team. They are based here in this facility as well, and they're here 24/7. It's not me, I'm not here 24/7, but I do help support that team. That's how I got started at Bradford White.
Wow, so were you a plumber, or how did you get into the water heater business?
It's a long story. I'll give you the condensed version. I was a broke college student. I was going to school for something that turns out was not in my future. And
well, you got to tell us what that was.
Well, that was nothing related to this industry at all. Essentially, English and psychology type of stuff, we'll say, which is pretty funny when I look back. But I interviewed with a small 5-man heating and cooling company, and they hired me in completely green, and they agreed to pay for me to take classes at night at the local community college, and I pursued an education in heating and cooling. I got my EPA certification, and I eventually went on in the field to do service work. I did commercial food equipment, commercial refrigeration, and residential HVAC. And I realized that I enjoyed supporting the contractors that I worked with. I became somebody that they would call with some technical questions. And ultimately, I responded to a job listing with Bradford White in technical support. And I ended up doing almost a decade of tech support here, about 8 years or so of tech support. And then I did some specialty product support before I became a full-fledged trainer.
That's really cool. So you're the person who answers the phone when they say, I'm having this problem with my water heater.
That's correct.
Yep. Oh, interesting. And are most of your colleagues former tradespeople that found themselves at the company too? Yeah.
Yeah, that's right. Everybody here in the tech support department is some flavor of either a past or current contractor. Some of our guys still work in the field. They moonlight as plumbers or HVAC technicians. We have a whole spread. We have master plumbers. We have HVAC background. I think as of right now, I'm the last food equipment service guy here. And we even have somebody that has an HVAC background, but he's also an ASC certified mechanic. So yeah, we cover the whole spectrum here as far as contractors go.
And where is the company located, or is it have more than one facility?
More than one facility, yeah. Where I'm at here, we're in Middleville, Michigan. I'm at our manufacturing facility where we make the tanks that are below 100-gallon capacity. Our corporate office is in Ambler, Pennsylvania. We started in Pennsylvania back in 1881. In the 1940s, we bought White's water heaters based here in Middleville, and that's how we ended up in both states, our manufacturing facility here in Middleville and corporate office in Pennsylvania. And then we have a couple of wholly owned subsidiaries. Our Square product, or that's to say our boiler product, is made in Rochester, New Hampshire by Lars. And then we also have Niles Steel Tank, which manufactures our large capacity storage tanks.
Wow, that's really cool. And how many folks are with the company? Do you know?
I don't know the number for the entire company. I can tell you that here in the manufacturing facility in Middleville, we're around 1,600 employees.
Wow, that's a big company.
Yep.
So can you please, you must have had to do a lot of homework for this interview because I gave you a bunch of hard questions and I appreciate your digging into it. I really do. But can you please tell me the approximate breakdown of how Americans heat their water? For starters, like how many tank style versus on demand are in the marketplace?
Yeah, the current numbers for the US market are up to about 90% of residences have storage style water heaters in them. And some of the numbers for specialty product, they're a little bit older. I don't think they represent the market currently, but essentially it's single digit percentages for when I say specialty product, we're talking on-demand product or tankless heaters, and we're talking heat pump water heaters. So those do still represent a small part of the market, but they have been growing very aggressively, especially in the last couple of years.
I'm guessing there's a breakdown with regard to fuel too. Do you know that breakdown too? I'm guessing that most of the on-demand heaters are either propane or gas-fired.
That's correct. Yeah, in most parts of the country, the cost per kilowatt hour is still prohibitive enough that if we're talking tankless heaters, we are typically talking natural gas or propane. And in residential applications, if we were relying on tankless, because there are tankless electric products out there, but in a residential application, we would need the available panel space to run something like that. That's usually not available in a residential application. So yeah, the vast majority, if we're talking on-demand or tankless, is definitely going to be natural gas or propane. When we're talking storage style tanks, it's about a 50-50 split. Approximately 48% of the country would be natural gas or propane, and then about 44% of the country would be electric style heaters. But it's going to vary a lot regionally. So say the southeastern United States, we have a lot more electric customers in those regions. And if we're talking natural gas or propane, we're usually looking at major metros are going to be natural gas versus propane will be rural areas.
Did you have to research this stuff, or did this part of your training as customer service rep?
It's funny you ask. The split between gas and electric is something that we deal with on a pretty regular basis here in the training department.
Sure.
But the percentages weren't something that I knew off the top of my head. I had to do some digging for that stuff.
I appreciate it. Can you talk about the basic operation of the three heater types, tank, on demand, and heat pump, and maybe the disadvantages and advantages as you describe them?
Yeah, let's start with the more simple operation of, say, a storage style water heater. We'll start with maybe residential electric as an example. In an electric heater, we have a thermostat, and it's going to look at water temperature in the tank. If we've decided, hey, we're below what the customer would like, and it calls for heat, it would send electricity to the heating element and bring that water up to temperature. We satisfy, thermostat shuts off. That's the simplest way to describe it. In electric heaters, we do typically have two elements. They'll usually run non-simultaneously, and different scenarios call for which one of those elements would run. If we translate that to a storage-style gas water heater, those heaters also would have a thermostat. It says, hey, the water temperature is too cool. It would call for heat and fire the gas burner, which is underneath the tank. We run that gas burner until we come up to temperature. Thermostat satisfies and shuts that burner off. And then when we move to product like a on-demand or tankless style heater, that's a unit where, of course, we don't have any stored water. And so we're not only relying on something like a thermostat that says, hey, what's the temperature of our cold water coming in? But we do also rely on flow. Usually across the industry, activation flow rates are somewhere around 0.5 gallons per minute or more. If we begin flowing, the tankless water heater would say, okay, I do see water flowing, it's time to fire. And then those units would modulate how much heat they put into the water. They look at how cool is the incoming water, what's the temperature the customer asked for at the fixture, and then those tankless units will constantly modulate, fire up and fire down. And then finally, with a heat pump water heater, those are unique because those are typically a hybrid format. Those would have resistive heating elements, so those work a lot like what we're used to in a standard electric, but they would also have a sealed system or a refrigeration system that is relying on heat transfer. Instead of creating heat by resisting electrical flow through an element, the heat pump is moving heat, and it's a lot more efficient to move heat from the space into the water than it would be to use a resistive element. So when we talk heat pump water heaters, those are units that are typically over 300% efficient. Our heat pumps are about 340% efficient. So I think that heat pumps are something really exciting, and they definitely work a little bit different than what we're used to on a standard style storage or on-demand tank.
One of the things I've heard, besides the good things I've heard about heat pump water heaters, is that they are a little noisy and they tend to make the space, I think it's cooler, but it could be warmer.
That's correct. Cooler. Yep.
Cooler.
You had it the first time.
Yeah. And what about some of the, I'm guessing they're probably more expensive too, right?
Yeah, you are dealing with something where there are more components on it. One of the really nice things about a heat pump style water heater is you do have two heat sources. So in essence, if for some reason we did have a situation where the resistive element side of a heat pump weren't running, we can compensate for that by running the sealed system side and vice versa. So of course, because you have more components, you have a little bit more of a complex control, you will add cost to something like that. But the efficiency savings are real. And heat pump, you were right when you mentioned that a heat pump does blow cool air into a space, but typically customers will utilize that to supplement their air conditioning. I've even seen some applications where that cool air helps as far as dehumidification in the space, although that does totally depend on relative humidity, usage of the heater, things like that. So we don't always lean into that as a selling point for heat pump water heaters, but they can certainly supplement with air conditioning. I've seen installations in the southwestern part of the United States where a heat pump is in a garage or an attic, and that cooling is a benefit because as we blow that cool air
ordinarily there
into
would
the
be
garage,
nothing, right? Yeah.
Yep, exactly.
With regard to tank style heaters, what's commonly better inside a more expensive water heater? Do they have better sacrificial anodes? And maybe we need to at first explain to folks what that is.
The anode is a complex one. I'll start off with the features question. Bradford White does not offer quality tiers for our heaters. We build them all to the same high quality standard. So when you select a Bradford White product, you're really selecting the right product for the application, and then you're choosing your warranty coverage. But we use all the same high quality components across the board. I am familiar with some other manufacturers that do, say, a good, better, best tier structure, but that's not really something that Bradford White uses.
What about the anode?
Anode rods are one of the most misunderstood components in a water heater, especially out there, even for contractors. I had a lot of questions in tech support. The anode rod, another name for it, is the sacrificial anode rod because it does break down and sacrifice itself over time to protect the water heater. And really what we're dealing with is plumbers will sometimes describe it as a filter, something that attracts bad things in the water to it. And it's not quite what it does. What we're dealing with is electrolysis. If you imagine anytime we join dissimilar metals in an electrolyte, in our case that electrolyte is water, one of the metals will start to sacrifice itself or give away electrons to one of the other metals. And if we didn't have an anode there, it could be the carbon steel tank that gives away little bits of itself, say to the copper water piping or the brass water connections, things like that. If we add an anode rod, the anode rod sacrifices itself to the tank so that the tank doesn't start sacrificing itself to other metals. And when we talk about that sacrifice, I mentioned it's electrons, or it's creating a very small electrical flow. What can sometimes speed that up is going to be water quality, things like conductivity in the water. So different markets, different water qualities, we will see different speeds of anode consumption. And it is a very important thing for us to stay up on when we're talking maintenance of the heater because it does protect the heater and extend its life.
What is the reasonable expectation for an anode rod replacement, or can you replace them?
Yeah, they are replaceable. They are a service component, and we recommend replacing them. Sometimes we get asked, does it hurt my warranty if I change the anode? And it does not hurt it. We recommend changing it. What we say in the manual is after the first 2 years to inspect your anode and see what the wear and tear looks like. Some water conditions, 2 years is going to be an acceptable window. Some water conditions, we could say, okay, this one doesn't look too bad. We could maybe go 3 or 4 or 5 years. And then some markets, even in the area where I'm at, where I've done some service work, I've seen it where maybe every year we need to change that anode. So it does totally depend on what the water quality is like. But in the manual, we say check it after the first 2 years.
Folks complain about how difficult it is to get them out of the water tank. Is there a way that is easy to get out? Can you put an impact wrench on it, for example?
Yeah, certainly. Breaking it free as far as the threads go. And the complaint I've heard as well is lack of headroom. And that's a challenge to get around. If we do have a lack of headroom, typically the anode can be angled as it's coming out. And I've used that a lot myself if I'm dealing with what we call a Michigan basement, which is a basement that's pretty much about as tall as I am. I've had
Why
to
does Michigan get picked
creative.
on with basement height? I want to know.
I don't know where that terminology came from, but I know it's what we always call it here. I'm curious. I'd like to ask you: have you ever changed your anode on your water heater?
Never. And I'm a hardcore DIYer. Most people would say I have tried to get them out. It is difficult because the tank wants to turn unless you have an impact wrench, and I've never tried to put an impact wrench on it. But I will try it next time.
Yeah, it's something we recommend, but I hear you there. It can certainly be a struggle. And Bradford White is a wholesale-only company. We're a little bit different than other water heater manufacturers, and we do distribute through wholesalers to licensed contractors. And so that's always a plug I throw out is we do recommend licensed contractors do the work on the heater, but I hear as far as if you've got the capability and you're trying to change an anode, nice thing is you don't have to drain the tank entirely. I know you mentioned the tank spinning a little bit trying to remove the anode. Typically, we just have to take pressure off and drain it down below say a few inches below the top of the heater. Sometimes that helps.
The weight helps helps hold it.
If you want to get aggressive trying to unthread it.
Oh, I'll be aggressive. What about, I've seen advertised on the internet, maybe other places, electronic anodes. And these are, like, I know used in infrastructure projects when you're dealing with steel and especially salt water because of the rust potential. Is that something that you guys get into, or what do you think about those?
Yeah, those definitely work. Electronic cathodic protection is something we utilize on our commercial condensing gas product, our EF family of heaters. So commercial applications, I think those are a good fit. I think we get questions from the residential side, and if you look at the most commonly applied residential heater, which would be an atmospherically vented gas heater, those are heaters where the controls don't use any external power. So those will go into a basement or a garage and maybe not have an outlet nearby. And electronic cathodic protection relies on a small module that plugs into the wall. And instead of an anode rod where we are passively and constantly giving off a small bit of electricity by the anode breaking down, these electronic cathodic protectors, they plug into the wall and they constantly generate that electricity with that module. So if we don't have an outlet or don't have a power supply available, of course, that's a challenge on the residential side. And I think the other thing is we would have to keep an eye on something like that. If we have power surges or brownouts that maybe affect that, homeowner would need to be aware of that, whereas the passive style anode is constantly, continuously protecting for several years without the homeowner being able to touch it. And as you mentioned, not a lot of homeowners do maintenance on their water heater. Not a lot of homeowners are familiar with the anode rod, and so it may be something that they wouldn't be checking on as much as they might need to just to make sure that it's protecting.
Sure. So how can people make their water heaters last longer? Let's talk about tanks first because they are the majority, and then we'll talk about on demand if you don't mind.
Yeah. Maintenance-wise, we do list maintenance suggestions, recommendations in the installation manuals, and the two biggest ones that I always express to people are that we change that anode. We talked about how that's slowly sacrificing itself, and if it's gone, then the water heater might start taking abuse that the anode would be taking. 2 years is the recommendation for that. And then the other big one is draining and flushing the heater. And I'm curious, so as a DIYer, have you ever drained or flushed your heater?
I have.
Excellent.
I have very hard water with a lot of sediment in it. I have an on-site well, and it's sandy soil, so I do, yes.
Yep. And that's the other big one that's going to extend life, especially if we're talking an electric heater. As scale and debris builds up in the bottom of the tank, that might reach the lower element. or if we have a gas heater, as scale or calcium or lime build up in the bottom, we insulate the bottom steel of the tank from being able to transfer the heat from the burner flame, and that will fatigue the steel and shorten the life of the heater. So those are the big ones. We historically recommended that the heater be drained completely and flushed out once a year, but we've since changed our literature to recommend that the heater gets just a few gallons run out of it once a month to try and help homeowners maybe stay up on that just a little bit more. So in that situation, heater doesn't have to be shut off. Electricity or gas can stay on, the water supply can stay on, hook up a garden hose and open up that drain, just let a few gallons flow out, and that helps sweep out any of that crud, like what you mentioned, or that scale and that lime. It flushes it out of there.
That's such a easier process than the previous one you described. Yeah, that's great.
Yep.
What about the on-demand heaters? My understanding is they need to have their insides cleaned out periodically with, I think it's vinegar, right?
That's correct. That's what we recommend is white vinegar. When you imagine the heat exchanger in an on-demand or tankless heater, what we're dealing with is a very small space where we're adding a massive amount of heat. When we talk about the input for tankless heaters, typically in the residential market, we're looking at 199,000 BTUs per hour of input. In contrast, a storage-style water heater in a residential application might be 40,000 or 50,000 BTUs per hour. And the faster we add heat to the water, the more quickly we precipitate solids out of the water. And that's, again, that calcium or that lime. We bake those things onto the inside of a heat exchanger, the more quickly we add heat to that water. Tankless heaters are very prone to water quality situations, total dissolved solids in the water, and typically those units should be descaled annually. But again, that's going to vary depending on water quality. Like you mentioned, if you're on well water, I'm on well water, I might have to descale mine just a little bit more frequently. But yeah, that's one of the most important things for a tankless heater is descaling.
Are there any clues to alert you when something is going wrong with either type?
No, unfortunately, there aren't really any cut and dry clues. That's a question I've gotten before in tech support. There's no crystal ball, unfortunately. One of the things that sometimes gets interpreted as a clue is if customers see a yellow coloration or a rusty brown discoloration on the hot water side at their faucet, and the presumption is that maybe the lining of the tank is failing. And that's not usually the case if we see that. Now, it's not to say that the lining couldn't fail. It's just to say that if we see a lining failure, that will manifest more as a leak. Mm-hmm. If we see that coloration, usually what we're dealing with is the anode rod is likely depleted. The anode does have a really skinny steel core wire inside of it, and as that becomes exposed, that corrodes or rusts, and then that's what's coloring the water. So sometimes even the things that I think the contractors out there presume might be a sign of a failing tank aren't always a sign of a failing tank. So yeah, again, there's no cut and dry way to tell. It's mainly looking at national averages or maybe averages in your locality, and then it's looking at how well was the heater maintained or how often was the anode changed. You
mentioned earlier that the two heating elements in a tank-style electric water heater don't work simultaneously generally. Mm-hmm. Is that correct?
That's correct. Yep.
I had the upper element fail on my tank one time, and it made scorching hot water. Can you explain what was going on there? Was the lower element trying to keep up? That's what I've heard.
That's interesting. It depends a little bit. Are you sure it was the upper element that had the failure, or was it maybe the upper thermostat?
I don't know. I replaced both because they sell them as a kit usually, so it's quite possible. But I believe I did a continuity check on the element, and it did not pass the test.
Got it. That's interesting. What I would suspect if the upper element did have a failure, if that was our cause, normally when we're dealing with an electric water heater, what we're looking at is when the tank is cold, the upper element is a primary. It gets the call for heat first. It runs and satisfies the top half of the tank. And once the top half is hot, the upper thermostat says, okay, everything's good up here. I'm going to allow the lower thermostat to run. So typically the upper does get priority. So I wouldn't suspect necessarily that the lower was running to compensate for the upper, because typically upper being a primary, eventually we get stuck with no hot water if the upper has a failure. I think maybe if you had an element failure at the top, it could be an unusual situation where if we picture the element as a loop or as a circuit, We apply electricity to it, and that electricity would flow along and produce heat as it goes through the resistive element. If we have damage to that element, say 3/4 of the way along that loop, and electricity is flowing there, the water could sometimes conduct that electricity and complete that circuit, make that element essentially make heat even though it's not being asked to make heat. So it's a pretty unusual situation. It's not common to see, but if that's what we were dealing with, if you had it where it was overheating and the upper element was bad, that's what I might have suspected. But I'd probably say I need to get in front of it with a multimeter to confirm.
Yeah, I probably should have done some more diagnostics too.
Well, it sounds like you took care of it, though. You said you changed the element.
Yeah, it worked fine then.
Huh?
After I put a new element and a thermostat in it, it was good to
perfect.
go. So what's the most common call that comes into the customer service department or email box?
Probably the most common question would be something relating to pilot outages. And that's mainly because there are so many factors that could contribute to a pilot outage. Again, residential atmospherically vented water heater is the most common format for heaters in the US, and those heaters do have a standing pilot. Things like combustion air in the space, building envelopes are getting tighter and tighter, and if we have a negative pressure in the room where the water heater is, an example might be if we run a range hood that pulls air out of the space, or if we have a radon fan in the basement pulling air out of the space and we don't have a way for fresh air to get in, we might lack combustion air. We could have the vapor screen in the bottom of the burner area get dirty. It will get clogged with dust or lint or pet hair, so we don't let fresh air get into the chamber, and then the burner chokes for air that way. And sometimes we can have venting issues. I've pulled my share of crispy critters out of vent pipes or bird nests out of vent pipes.
Sure.
And even unusual cases like, say, in Texas, water heaters typically go in the attic. If the attic is not ventilated properly during the summer, the attic gets really, really hot, and we don't induce a draft because it's so hot in that space that we don't really follow the heat rises principle. So I'd say that's a really common one, is dealing with pilot outages and what might contribute to those.
What about the weirdest thing call you've taken?
Weirdest thing? I've had a lot of weird ones over the years.
I can't wait.
I'll say one example is I had a situation where the neighbor kid took the garden hose and put it in the vent pipe and ran water down into the basement. So the burner chamber, everything full of water. Along those same lines, I had one where this was one of those ones where it probably wasn't the neighbor kid, it was probably the customer's kids, but didn't know what it was. I get to the unit, and it's calling for heat, it's running the blower, and it's not closing the pressure switch, which is the safety switch for the blower. So I begin doing some testing, and I say, hey, I'm not really moving air through the vent like I should. And I disconnect the vent pipe, and one of the kids had put landscaping rocks down the vent pipe. And the pipe was about 6 feet high, full of rocks. And so when I disconnected it, about 50 pounds of rocks come out in the basement. So things like that. It gets interesting out there in the field.
So I got to ask, the youngster who put the garden hose in the direct vent appliance, was that an on-demand heater, and was that toast after that fact?
It was not an on-demand heater. Interesting thing about a on-demand unit would be if we did send water down that vent pipe, the water would go through the heat exchanger, which the heat exchanger is designed to handle condensate.
Sure.
Because they're so efficient, they produce condensation as they steal heat from the exhaust. So if we ran water down that exhaust pipe, it would end up going out through the condensate drain that's built into the tankless. So we might not know it, depending on how much water we sent down the pipe. So yeah, if we had water going down a vent pipe on a tankless, maybe we wouldn't catch that.
A few years ago, I learned about the problem of orphaned water heaters, and I suspect you know what it is, but for the benefit of listeners, it's when someone converts their gas furnace or boiler to direct vent that previously was atmospherically vented, and often in old houses, the water heater and the heating plant for whether it's a furnace or a boiler, go into the same masonry chimney. And when you don't have the load of that big boiler or furnace creating heat in the chimney, it reduces draft for the water heater, and you can have spillage. Did I explain that okay?
You got it. You're doing great so far. You're going to join us here in the training team for Bradford White?
What do we do about that as an industry?
That's a good question. That is, you hit it spot on. Really what we're dealing with is if we picture the furnace and the water heater, they produce a certain amount of heat in their venting, and when they're combined, we would do a vent that's sized for that level of heat. When we delete the furnace, say we replace it with a 90 plus efficiency, the furnace uses PVC venting through the sidewall, we suddenly have a water heater that maybe wants to use 3-inch or 4-inch vent pipe that is going into a vent that used to be combined, so it's maybe 6-inch or 7-inch. And as the warm air or hot air rises through that vent, it begins to cool because it has so much space to occupy, and we produce condensate. That condensate is acidic. It starts to eat the pipe. Lots of bad things happen in those cases. And so really the solution is we would have to typically do some kind of a liner, depending on what the configuration is, maybe replacing the venting if it was vent pipe that was run all the way up to the roof. But many times when we had the furnace and the water heater common vented, they stubbed into a chimney. And so we might pull a chimney liner down through that chimney and reduce the interior diameter back down to that 3-inch or that 4-inch size that we're looking for just the water heater.
And as I understand it, that's like a stainless steel flexible pipe you drop down there, and I think you can like insulate it with vermiculite. Is that what you put around it sometimes?
Yeah, that's correct. You could insulate those. The ones that I've pulled, I haven't seen insulation, but it's certainly doable. And they are stainless, exactly, because we are dealing with that corrosive condensate, so we would need to do it in stainless.
Can I guess you pay more attention to hot water and hot water delivery when you're out and about in restaurants and stuff? What drives you crazy? I'm sure you go to friends' houses and count how long it takes to get hot water at the lavatory, right?
That's fair. Yeah, I think that's probably fair to say. I do pay attention more to that stuff. There aren't too many things that bother me just because I've seen so many unusual cases working in the tech phones. But it's something where, you mentioned DIY, and I know myself, I'm an amateur mechanic at home, but sometimes when we're supporting product and we see those cases where customer had good intentions, they install the water heater, but maybe it's not sized appropriately, or it doesn't meet local code, or worse, it's not safe to run. Sometimes that stuff gets a little bit bothersome, but yeah.
Yeah, because the stakes are high, right? This is important stuff. This is not to be messed around with.
Exactly. And especially with modern products, as legislation affects water heaters more and more, we see more and more safeties, we see more and more complexity, and even as we see those green pushes in the industry, we see water heaters having to utilize more complex components and more complex sequences of operation, and so that doesn't always lend itself to a one-size-fits-all, or doesn't always lend itself to a DIY approach.
What about when it's like stupidly hot? You're just like, this is dangerous. And I mean, I've been in restaurants where they clearly don't have tempering on the, bathroom sink. They're using the hot water that they would be sending through the dishwasher. And I was like, that doesn't seem like a good idea.
I agree. Oh, that's a great one. Yeah.
So you mentioned that you are an amateur mechanic. You work on your own cars, or does that take other interests too? Tractors, motorcycles, go-karts?
Mainly cars. I do have a motorcycle. I like to tinker on that just a little bit, but yeah, mainly cars. I still can't get past that work on it myself streak that I have, which is part of why I pursued tech support as well. It was something where I didn't want to give up troubleshooting, repairing things, but sometimes life in the field, when it's Saturday night and you're on call and you have to go out onto a rooftop in 3 feet of snow, I don't always miss that part of the service side of things.
I believe it. Do you work on the house too? Do you have your own home?
Yeah, I do have my own home. Yep. I do, just about anything at my house. I need a new roof currently. That's something that I'm pursuing, and I haven't decided yet if I'm going to tackle it solo, or rather tackle it myself, or if I'm going to hire that out.
Is it steep?
No, it's not bad. Not bad.
I don't know what to tell you. Like, roofing is often very affordable, and it's backbreaking work, but it's not hard. It's just a lot of work. A whole mess of work is what my wife would say.
Yeah, well, and you hit it on the head as far as cost too, right? The economy right now, material cost, it makes it a little bit tougher to decide.
So what's the next addition to the lineup of water heaters in your backdrop, Spencer? Is there one? Is there one that's not represented right now?
Right now, there is a new product that's back there. It's brand new as of yesterday, actually. We just put it into our
What?
lineup back there. It's the white cabinet, the on-demand unit. We dropped a new family of on-demand tankless water heaters, and it's something that I just went through training myself a couple of weeks ago, and it's something we're very excited that we just launched. So I'd say that's definitely the newest.
Cool. Well, it has been a pleasure talking to you, Spencer. Thank you so much for your time.
Hey, that's not a problem. Thank you very much for having me.
Is there anything you'd like to ask or tell our audience before we part company?
Just a little bit of what we've touched on previously, that if you are a homeowner and you're looking for a replacement water heater, we always recommend get in touch with a local professional. We have excellent tech support available if you do have questions, and we have resources to help you find local contractors. And for the contractors in the audience, Bradford White is wholesale only, and we do have an excellent training program. It's something that I really, really enjoyed in my time in the field, was expanding my knowledge base and pursuing a better skill set. And so Bradford White is happy to accommodate and help in any ways that we can. We have an excellent e-learning offering. We, of course, do in-person training here in our live fire lab, and then we have some virtual offerings as well. So definitely pursue that training and become the best contractor you can be.
Where can folks find those things on the web, Spencer, that you just alluded to?
At our website, bradfordwhite.com, and we do have a portal that's just for contractors. It's called For the Pro. It's our For the Pro Academy is the entire training package. So if you go to the website, bradfordwhite.com/For the Pro, you will find links, videos, resources, lots of really cool things on that website.
Excellent. Well, unfortunately, that's all the time we have for today. Thanks to Spencer Pope for joining me, and thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us however you're listening. It helps other folks find our podcast. Stay safe, everybody. Keep craft alive. Spencer, thanks a million.
Hey, thank you very much. Take care.